Hello, welcome to the How to Factor video. Okay, so we're just going to go over some factoring that we learned in grade 10 and then we're doing again in grade 11. And it's all different types of pretty much quadratic factoring that we need. Okay, so here's our little factoring flowchart. So when we get an equation or an expression, so let's say we get an expression that looks like this. X squared plus 7x plus 10. There's our expression that we're given. So we're going to take a trip through this flowchart. So the first thing we're going to do is we're going to check for common factoring. So we're going to look at our equation and we're going to say, hey, let's look at each term. There's 3 terms there. Are any of these terms all divisible by the same number or the same variable? Okay, so they all don't have an x, so no. And this guy is 1, this guy has a 7, and then the third one has a 10. So none of those numbers have a common factor or something that you could divide each number by, so there are no common factors. But we want to check that first. So we're trying to see if there's, can we divide each term by the same number or variable and variable. Okay, so we want to check that first. So if we can, do it. If we can't, or even if we can, we move through our factoring chart. So after we do common factoring or realize it doesn't work, then we're going to go down to the next 2 parts of the factoring chart. So here we come to trinomials or a difference of squares. So now we have to check, okay, how many terms do we have? Trinomials have 3 terms, and they're always of the form ax squared plus bx plus c. So meaning they'll have an x squared term, an x, and then a constant, so like a number on its own. So they'll look like that. So if you check out our expression that we're doing as an example, this guy up here is a trinomial. It's got 3 terms, 1, 2, 3. It's got an x squared, an x, and then a number. So it fits our trinomial thing. And just so you know, the other one, difference of squares, this guy only has 2 terms. So we know right off the bat that's not going to be a difference of squares. Okay, so trinomials. There's 2 categories for trinomials, simple and complex. In a simple trinomial, a is equal to 1. In other words, your equation would look like this, x squared plus bx plus c, where b and c are just some numbers. In a complex trinomial, a would not equal 1 or 0. So you would have some number like 2x squared plus bx plus c. Okay, so once you determine which one it is, so if we look at our example, we have x squared. So if you look at that x squared term, technically there's a 1 in front of it. Either way, there's not another number like 2, 3, or 4. So we know though the one we're doing is a simple trinomial. So our question, the example I was doing, was x squared plus 7x plus 10. So how we factor our simple trinomials is they're going to factor into 2 brackets. Since this term is x squared, we're going to put an x at the front of each bracket, which will give us our x squared term. Then this 10 at the back is going to help us figure out the end parts here. So that means we want 2 numbers that are going to multiply to 10. So we want to try to find 2 numbers that are going to multiply to 10. And then we also want those 2 numbers to add to 7. So that way when we're expanding, we know we'll add up to 7 and we'll multiply to 10. So our 2 numbers are positive 5 and positive 2. 5 times 2 is 10 and 5 plus 2 is 7. And there you have it. It is factored, simple trinomial. Okay, complex trinomials, let's do a quick example of that. They look a bit different. So they're going to have a number in front. So they could be something like 2x squared plus minus 6, for example. So that's a complex trinomial. It's made up of 3 terms, an x squared, an x, and then a number, and it has a number in front of the x squared, so it's complex. So in this method, eventually it's going to factor into 2 brackets, just like our simple trinomial. So just right off the bat, I know it'll be like a 2x and an x. I'm just not really sure what's going to go in the backs of the brackets. But I do know those numbers are going to end up multiplying to 6 and adding to 1 once I expand it. So same principles. So you can kind of like guess your way through it, or you can use one of the methods I taught you in class. So the one I went over with everybody was a method called decomposition. So you can use that method to factor a complex trinomial. There's also the Crisscross Method or the Australian, there's like a whole bunch of stuff out there. So if you choose decomp, so what you're going to try to do is, first you're going to multiply this guy and this guy together. So 2 times negative 6. So you're going to try to find a number that multiplies to negative 12, and then a number that adds to the middle one, a number that adds to 1. So what multiplies to negative 12 and adds to 1? I'm going to say negative 3 and positive 4 will be our numbers that we're going to use. So once you figure out your numbers, those numbers are going to replace the middle term. So we've got 2x squared minus 3x plus 4x minus 6. So we just determined the 2 numbers that'll work, negative 3 and positive 4, and we've just replaced our middle term with those 2 numbers. Okay, now we're just going to kind of split our equation in half, and we're going to common factor each half. So when I look at 2x squared minus 3x, the only thing they have in common is an x. So I'll factor out an x. So now what I'm doing is I'm dividing each term by x. So my first term, I'll just have a 2x left, and my second term, I'll just have that minus 3. Okay, then I'm going to bring down this positive sign, and I'm going to look at the next 2 terms, 4x and 6. What do they have in common? Well, they're both divisible by 2, so I'll factor that out. So that means now I have to divide each term by 2. So that gives me 2x minus 3. And check it out, the brackets are identical, which we want to happen every time we do decomposition. So since the brackets are the same, technically what you have here are 2 terms in our expression, and the 2 terms have 2x minus 3 in common, so I'm factoring that out, and what's left is x plus 2. So final answer is 2x minus 3 and x plus 2. So things to notice are 2x times x ends up giving us our 2x squared term. Negative 3 times 2 gives us our minus 6. And when you expand this out, you end up with the plus 1 in the middle. So you don't have to use this decomposition method to find the final answer, but it is a strategy to factor it. Another strategy, just while we're talking, that some people in the class use is that chart, the crisscross thing. So just to give you a really quick explanation of the crisscross method, it involves, I'm just going to rewrite this equation over here. It involves just seeing what multiplies to the outside terms. So what multiplies to 2? 1 times 2. And then I'm going to write the other option, which is 2 times 1. Same thing. And then I'm going to write down what multiplies to 6. So 2 times 3 or 1 times 6. And since it's a negative here, I know one of these values has to be negative. So maybe the 3 is negative, maybe the 2 is negative, maybe the 1 is negative, maybe the 6 is negative. So those are kind of all my options for what multiplies to negative 6, and I just list them in columns. Now what I'm going to do is I'm going to crisscross things. I'm going to cross multiply, and I'm going to try to make them add up to 1. So for example, let's say I was testing out this column versus this column. So I'm going to multiply across. What's 1 times negative 3? Negative 3. What's 2 times 2? Positive 4. And if I add those together, negative 3 plus 4 equals 1. Hey, that's what I want it to equal. Sweet deal. First one I picked worked. So you're just kind of crisscrossing to see what works. So once you find the ones that work, so we didn't actually need any of these because our first one worked. So that's the ones that work. So technically, this is going to be one of your brackets, and this is going to be your other bracket. So the 1 and the 2 means x plus 2, and the 2 and the -3 mean 2x minus 3, which is what we had there. So that's that crisscross chart method, whatever you want to call it. Okay, and our final factoring thing that we have not talked about yet is a difference of squares. So I already said that a difference of squares has 2 terms only. Some other important things are the 2 terms have to be separated by a minus sign, and both terms must be perfect squares. In other words, you can take the square root of them and you'll get a whole number, not a decimal. So here's an example of difference of squares factoring. Say you had x squared minus 25. So let's check. We have 2 terms here, 1, 2. They're separated by a minus sign right there. And I could take the square root of both of these things and get a whole number. Meaning the square root of 25 is 5 and the square root of x squared is x. So then when we go to factor a difference of squares, it's really quick. We just take the square root of each number, each term. So x is the square root, and the square root of 25 is 5. And then we make one bracket a plus and one a minus. And what you should notice is difference of squares are technically simple trinomials without a middle term. So this could also be written as x squared plus 0x minus 25. So it's actually the same thing. So it's actually a simple trinomial. So you're looking for 2 numbers that multiply to -25 and add to nothing. So those numbers are +5 and -5. Because they multiply to -25 and they add to nothing. So you could kind of think of them as simple trinomials with a 0x middle term too. Awesome. And then obviously there's combinations of these things. So I could also give you things that might look like a complex trinomial, like 2x squared plus 10x plus 12. You might think, boom, complex trinomial because it's got 3 terms and there's a number in front of the x squared. But if you recall from our factoring flowchart, common factoring is the thing we always want to check for first. So in that example, technically, all of these things are divisible by 2. So you can just write the 2 out front. And if you common factor out a 2, it needs to remain there. Don't just get rid of it, or else you've changed your question. And you can't do that. Okay, then after you factor out a 2, you can look at this expression in here, and you can say, that looks like a simple trinomial. I wonder if it's factorable. And then you're like, okay, what multiplies to 6 and adds to 5? How about 2 times 3? Then boom, common factored and simple trinomial factored, all in one. So that could happen. You could have multiple factoring types in one. I could also do that to a difference of squares. I could say 2x squared minus 8. And you're like, oh my gosh, that looks like a difference of squares, but like I can't square root the 8. Weird. And then you think to yourself, oh yeah, I'm supposed to check for common factoring first. So you look at each term and you're like, they're both divisible by 2. So I factor out a 2, and then I get that. And then I'm like, oh hey, what's in the brackets is actually a difference of squares. So I need to factor that into 2 brackets, x minus 2, x plus 2. Boom! Common factored, difference of squares factored. Okay, sorry for the super long video, and I hope you understand factoring.